Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. So in this live stream we're going to try something very interesting. That was going to be very challenging for me, but we'll see how it goes. So yeah, let me share the link with my Discord server and Godot Discord server. So please join my Discord server. You can find the link below in the description. I'd be glad if you join. And yeah, let's see. Come on. I hate this. Finally. Okay, let's go. And there you go. Okay, so let's grab the chat and let's get going. And Isa Ismail, welcome to the live stream. How's it going, man? That was instantaneous, man. That was instantaneous. Okay, let's see. Right. Let's go. Whoops. There you go. Okay, nice. Alright, let's start pretty much. I think so. Let's keep going. This is gonna be a lot of fun, I guess, hopefully. Let's go. Okay, so I'm gonna be working with Godot Engine C# support and of course with Rider, and I'm gonna be working with Rust Rover for Rust. And yeah, let's get started. Pretty much. So let's create a new project first of all, and let's go. So I'm not sure what to call this. I guess let's say matching bracket. Sure, let's name it that, I guess. Creating folder, creating edit. Let's go. And all right. And let's create a new project, Rust project 2. Of course, the server would be, you know, like separate or independent from the client. So, okay, let's make a new project. Matching bracket server. And let's create binary. And let's get going. We're going to be using Tokio, so we're going to be using async and multi-threaded Rust stuff. So, 2. I'm not very experienced with servers and async and even C#, but we're going to see how it goes. We're going to learn as we go, I guess. And yeah. Okay, so let me set up this. So we're going to need Tokio. And we're going to need... what is that log crate called? Async log. Async log Rust. I forgot. Yeah, tracing, exactly. Okay. Tracing, and so that's just the interface. So we need tracing subscriber, which is going to be like a Rust tracing subscriber, which is going to be one of the implementations. So yeah, we're going to go with this one too. These are for the Rust libraries that we're going to need, at least for now. And cargo B. Compile everything. Let's make sure cargo check is on. And let's go to save actions. I don't know why the setting doesn't persist between sessions, honestly. It drives me insane. Well, let's reformat code. And there you go. Okay, cool. Lovely. Oh, why can't debug run this? What the heck? Oh, it's still indexing. Okay. Okay, let's try to debug this. Great. Perfect. Okay, let's go, I guess, to the Godot side. And we're gonna start very simple. We're just gonna create a very simple UI, which, you know, you can just put some messages in, and that's basically gonna be it, I think. And we're gonna try to like create a client on the Rust, on the C# side, and a server on the Rust side. Hello, I'm Slal Flappy. Welcome to the live stream. How's it going? So yeah, let's get going. Pretty much user interface. I don't know what you call it. Let's keep it that way, I guess. And let's just go right away. And let's go with the scroll container, yeah. Well, actually, before that, let's go with the VBox container, though. I think. Let me think. Hold on. Actually, let's go with the margin container first, right? And then, oops, hold on. So we're just gonna make a very simple UI real quick, and we're gonna go with the VBox container. We're gonna go with yeah, and then we're gonna go with the scroll container. Right, that's gonna be the body, like where the messages will reside. What is this stream about? We're basically gonna be trying to make a chat application from scratch using Godot and C# in the client side, and using Rust, async Rust with Tokio on the server side, basically. So yeah. Okay, so we got a scroll container. We're also gonna need a line edit, pretty much. Suffering doing chat. Exactly. Okay. Actually, let's remove the margin container, really. Let's remove it from there. And I'm gonna put it actually here instead. Margin container with a scroll container there, and another margin container with probably a line edit for now. For the input, we're gonna put the line edit down. We're gonna anchor it to the bottom side. So a line, what the heck? Oh, I see, never mind. Let's actually make this expand to take the whole space. Glad to hear, that's crazy. Yeah, it is crazy. That's what why we're trying it today, so. Okay. So, and we're gonna have some messages here. So for the messages, we're gonna go with I guess let's start with probably a panel. Let's go with a panel. Why not? Or we could go with a panel container too, I think. Panel container, and then we're basically gonna have like a label on this thing, which would basically contain the text. Hello world. Though I'm gonna have some margin container here to keep some margin. Okay, because this looks ugly as I don't know. Let's go. Okay, so I'm gonna need to add a theme though. Hold on, let's add a new theme, and let's make the theme. Yeah, let's add margin container here so we could actually change the margins. So add type, and I'm gonna add the margins maybe 4 pixels. Okay, that looks not bad. Great. Okay, so basically what we're gonna have here is, oh yeah, I forgot about the VBox container, my bad. VBox container, and we're gonna have this guy here. This guy should take the whole space. There you go. And that's nice. And okay, so let's make another message. So basically this is how the messages would look like, I think, for now. Very simple stuff. I mean, we could also maybe go ahead and put the author too of the message Why not? So like we could have like a VBox container where you're gonna have the label here and another label again, and this is gonna be like the, you know, who said the message, I think. We could go with that. Theme overrides. But yeah, well, honestly, let's keep it very simple. We're just gonna have the message for now there, and that's it. Very, very simple. Okay, cool, lovely. So we got something, we got some little UI here now, some very basic UI, so we can start to do some testing. Come on, bruh. Okay, there you go. And so we're gonna be able to write some stuff, press enter, and it would need to add the message here. Now, since we're gonna actually add multiple messages here, we're gonna instantiate it multiple times. I'm gonna actually go ahead into this panel container, right? So this is our message here. So we're gonna make this into its own scene. Save branch as scene, save. And there you go. Okay, lovely. And here we're gonna create a script. Of course, it's gonna be C#. And let's call it main. Why not? And let's create a script now. I don't know why I didn't change the name. Anyways, main.cs. Okay, and no thanks. We're not gonna be using this. We're gonna be right, let's see what we got here. So let's open this into a writer. Okay, there you go. Okay, let's open this into a writer, trust and open. Okay. Okay, install automatically, update, and yes. Okay, let's go to main.cs here. Perfect. Perfect. Okay, so the thing is, I've created a server, you know, just a basic server before in Rust, but I have never ever made a C# client. So let's find out how. C# client, let's see, docs, or TCP, yeah, TCP client. So we're gonna be using TCP, of course. So okay, there's a TCP client here in .NET, which provides client connection for TCP network services. Cool. And this is how you do it, basically. You create a client, then translate the passed message into ASCII, get a client string for reading and writing, send the message to the connected TCP server. Okay, right line. Nice, perfect. Let's actually just start with Rust first, really. Let's start with the server, why not? So, let's, what should I call this? I don't know. TCP listener. Okay, between a local. The heck, I already forgot how to do that stuff. Well, Tokio server. Well, Tokio TCP server. Right, TCP listener. Okay, there you go. So TCP listener bind. So they called it listener, sure. So TCP, okay, what the heck is going on with you? Okay, there you go. That's weird. So bind, and here we're gonna go with the address. So ADDR, so let ADDR is equal to socket ADDR from are actually, yeah, let's go with new. And then here we're gonna need IP ADDR. Let's go with v4. And then here what we need, what the heck, v4. Okay, so it's basically this. All right, so should I say IPv4 ADDR new, and here we're just gonna say 127.0.0.1, I think, for localhost, and then the port would be, I don't know. Okay, TCP listener bind, and let's go with just in wrap. If we couldn't make a TCP listener, just crash and burn. And let's go to the next thing. Okay, so now what's next? So we're gonna basically loop, and we're gonna wait for connections. So listener accept await. Oh my god, what I've done there. Okay, oops. So loop let socket, I think, and it also gives you the address, and it's equal to listener.accept. And oh yeah, I forgot about Tokio main. So since we're going to be using Tokio for async, we're going to do Tokio main, and here we're going to say async. And oh, I actually forgot one thing for Tokio. We actually got to add features full for now. And there you go. Now listener.accept .await, I think, and then in wrap probably. Okay, the IDE seems like to be indexing right now. Okay. All right. Still indexing. Okay, there you go. Now expected TCP listener found. Accept await. Remove the, okay. Hold on a second. Yeah, I see. So we're not using the TCP listener of Tokio here. Tokio net TCP listener, not the standard library one. That's why it didn't want await. And we probably want await here too, yeah. There you go. Okay, so now we're gonna basically keep on getting new connections. And after that, we're basically going to spawn a new thread for that connection, or like a new task, kinda. So, or future, anyways. So async, there you go. Move async though, I think, right? Move async, yeah. Oh, well, actually it's probably async move. Try, yeah, exactly. Okay, let's go. All right, let's look for some more examples now. So, okay. So, socket dot. Okay, can I? Yeah, I can actually read stuff and so on. So that's cool. Okay, let's try to maybe write something. So I guess let's try to. Why there's no write stir? Interesting. Okay, so let's just write all. And here we're gonna go with B for bytes, I think, and then we're gonna go with, let's just say hello world. Let's just try this out. And of course the await, probably the in wrap too. And there you go. So this should be mutable apparently. And there you go. And we're not using the socket address for now. That's the socket address of the connection. So now we're just basically launching a server that basically takes connections and writes to them. Once it's connected, it writes to them hello world. As simple as that. So let's actually launch this server. So yeah, it's gonna compile, of course. And then we're gonna move on to making some simple client, pretty much. Okay, so I think right now it's working. Though, other than that, let's actually go with. Let's get Copilot working, honestly. And let's go with what is that called? No, tracing. Okay, so initialize tracing. Let's go exactly. Cool. So I don't waste time, keep on googling stuff. There you go. All right, so tracing subscriber, and then after that we're gonna say info listening on, or let's say server start on address, right? And then here we're gonna say info, or maybe a sworn actually, even, why not? And let's actually import that and accepted, or let's just say client connected. Actually, let's say this server start and client connected. Okay, so here let's go with address. And here, once we actually go out of this, it means that we're gonna basically be client disconnected, right? And there you go. Alrighty, perfect. So now server start. Cool. Now let's actually make the client. So let's see. Var client. Okay, let's see how to do this again. TCP client. So equal to new TCP client. There you go. What do you mean? I'm pretty sure you can use var, right? What the heck? Oh, is this like maybe some older C# version or something? Weird. Anyways, so we got a TCP client now. Now we basically gotta have a new TCP client server, and okay, so you give it the server and the port. So the server would, is that like, oh, string, server is string, okay. So I guess this, and port would be basically 6969, okay. And there you go. Okay, so we have created a TCP client. Now we gotta do, send the message to the connected TCP for reading and writing. Okay, so var stream, exactly, client get stream. And now we're just gonna basically be reading, since the server is writing right now. Yeah, so we're gonna be reading data. So let's try to read some data then. Read. Begin read timeout. So reads the data from the network stream and stores it to a span of bytes in memory. Interesting. well, yeah, read. So data, it's new byte, okay. Though I believe you can actually do it on the stack though. So create buffer on the stack. I don't remember how though. Crap. I think it's stack alloc, right? I think so, yeah. Nah. Stack alloc. Is that how it goes, I think? Cannot use in safe. Actually, you know what? Let's just go simply with new byte, pretty much. Well, where's that thing? New byte. Okay, let's just go with this anyways. And what's up here? Built-in type is inconsistent with code style settings. Okay, so now here we gotta read, and we gotta need to give it the buffer. And yeah, that's pretty much it. Return value is not used. Fewer bytes can be read than requested. Okay. So it basically gives us how much bytes we got. Or data. Well, I don't know what you call this. Let's say bytes count. Okay. And let's just, after that, we're gonna basically print it. Print buffer as string. Come on. Crap. Okay, let's see how we can do this. Stream. Okay, let's say console.writeLine. Buffer. And let's see how this goes, pretty much, I think. So, yeah, let's actually run this now. The server is already running, so. Build succeeded. And build completed. Can't run project no main. Ah, okay, I see. So let's actually run it from here. Select current. Okay. There you go. And can't run. Let's try again now. And we got no bytes. Okay. Client connected, client disconnected. So we did indeed connect. So that's nice. But why we didn't get anything? Interesting. Okay, translate the pass message into ASCII and store it as a byte array. Okay. Are we sure we're actually doing that correctly though? Socket right all. Yeah, that should work. Just to make sure, let's remove the Tokio spawn real quick. Okay. And let's try this out. Well, actually, let's debug. So we are connecting, but we're not getting any bytes. Interesting. Okay, let's try the other way around though. Why not? So, let's just make use of this pretty much. And let's go with byte data. Well, you could just say var here. Var data is equal to get bytes message. Now the message, let's say hello world, yeah. And I believe Daniel Ahmed Rizaldi, welcome to the stream. You get the byte, but console write line only shows system byte. Oh my god. Yeah, I just remembered that stupid C# login stuff. Yeah, thanks for pointing that out. So yeah, it's probably maybe even working right now. Yeah. Okay, so apparently I guess maybe you do it like this. UTF-8 get string buffer 0 bytes count. Okay, let's try this out and see if it works. Sure. So is the server on? Yeah, it is. Okay, let's try this out. Okay. Okay, there you go. So it's actually working. You just saved me like a day of debugging. Thanks. Okay, let's go. So here we basically read some bytes, the bytes that are there, and we essentially turn that into a string. And there you go. So great, we got our first message from Rust into C#. Perfect. Now let's actually add some stuff here. So basically what we want is every time we, like the user, you know, press enters on this box, on this line edit, what we want to do is we want to, you know, like make a new message here and then send it to the server. Then the server, for now at least, to keep it simple, just gonna give us back the same message, and then we're gonna print whatever that message that the server gave us. So basically we're gonna have hello world, hello world. So like the message twice basically. So yeah, let's try this out. So here in line edit we have text submitted. Okay, so let's go with that. Alright, so let's see. Okay, so we don't want to do this now. Var stream, should I? Returns the network stream used to send the receive the data. Okay. So now let's see what we got here. So first of all, we need to get the node. So how are we gonna do this? Well, I mean, we could just say, well, in fact, we are inside of it, my bad. So what we need is text submitted now. Text submitted event handler. Did I really forget how to do this? Oh my god. Crap. So Godot C# event handler. Godot signals. Okay, so my timer dot timeout. I guess then maybe self. What the heck is going on here, bro? Really? Oh, this is. What the heck? Oh, I'm stupid. So this is actually inside of the main here, not inside of the line edit. So I gotta actually get the line edit, my bad. So let's actually, okay, let's see how we could do it. Well, we could just basically, first of all, this is the user, or like the message input box, I guess. Or the message input, let's say, maybe. And then let's make this unique, access is unique name. Okay, and then var message input is equal to get node, right? So get node line edit, yeah. Message input, though I think you probably want this for the unique name. And yeah, let's see about that. And then after getting the message input, we gotta go with text submitted plus equal to. So we're gonna get the oops, we're gonna get the text, right? And here we could do whatever we want with that text, pretty much. Okay, so the question is what we're gonna do with that text. So, okay, that's perfect. So we're gonna get the bytes from the text, right? And then we're gonna write it to the stream. Looking good, yeah. Though, yeah, let me actually put the stream here instead. So, okay, cool. Or, yeah, I forgot that actually C# is have garbage collection, so that would be fine both ways, yeah. Okay, cool. All right, so let's try this out. And here though, in Rust now, what we're gonna actually do, we're gonna try to read data instead. So, so socket dot. So we're gonna keep on looping though. We're gonna keep on looping, and we basically, yeah, there you go. The AI have already caught up. Let mutable buffer. So we're creating a, well, actually instead of this, no, that's a bad way to go about this. Let's make a buffer reader. No, buffer reader. Okay, good. Why the heck it wants that? I don't know. Anyways, so let's actually read. Yeah, I could probably read a line. Interesting. Yeah, okay. And here we're just gonna need, so you're gonna have the message is equal to a string new. So basically the buffer reader actually does that buffering for you inside of it. So like it have that buffer and it keeps track of everything. And then it also provides you with functions like readline and so on. Here I'm gonna actually tell it to put it inside of the message string. And though we only need one message string per client. So client connected. So let's put it here. Though I don't think this clears it, of course. So let's just make sure to clear it. Though honestly, let's clear it here instead even. Why not? And this should be mutable, of course. And there you go. Unreachable statement. Oh yeah. So, okay. Well, actually, readline doesn't. So it returns. So if successful, this function will return the total number of bytes read. If this function returns OK0, the stream has reached AOF. Okay, so let's actually match on this. Right. So, okay. So OK0. Then we get a break out of the loop. Because we got no message from the user, I think. And what's up? What's going on here? Oh yeah, we gotta await this. And yeah, there you go. And okay, this gives us how much bytes, but we don't need that, I guess. And if there's an error, then we're gonna actually, well, not error, not warn. I'm gonna go with error here, and then yeah, that seems good to me. All right, let's actually try this out. Though, I think I probably want to add a new line when I write this message. So I don't think text would include the new line. And that read line function actually basically keeps on reading bytes until it reaches a new line. Of course, we're going to change this soon. But just as a start, you know, we're trying to, you know, keep incrementally building this thing. So, okay, let's see. So the server is running great. Now let's actually try this out. And just make sure there's no errors or anything strange for now, at least. Okay, so object reference not set to an instance of an object. Interesting. So yeah, this is null for some reason, so I'm probably doing something wrong here. Message input, is this the correct name though? Really? Or maybe did I forget how to use Godot unique name? Unique nodes? No, that seems good to me. So what the heck is going on here? Oh. No. Message input. That doesn't make much sense. Let's try again. No, message input, no. Yep. But why? I mean, I made this a unique node. Really? What if we copy the node path then? And just said this instead? What? Really? I don't understand why unique names doesn't work. Anyways, so I guess maybe this works now? Maybe? So if I actually pause this... Oh, I can't, so I have to actually put a breakpoint. Oh, okay. But in fact, before that, let's write... Well, yeah, we're actually already writing all the message to the client, but we're not actually listening to that, though. So let's actually do that. So stream. I'm not sure if I'm supposed to actually store this, but let's store it. Like what this does actually. Can I see? External sources. Nah, that's not useful at all. Okay, cool. So network stream private, network stream is equal to, and so stream is equal to client.stream, and there you go. Well, in fact, can we just say this? I don't think we can. No. Yeah, no. Okay, cool. And now we could actually use stream here. So stream dot read. Read. And we're gonna need some buffer, yeah. So buffer is equal to that, and let's give it that, and var bytes count. Okay. Now let's actually say console.writeLine gets string, yeah. And let's try this out. There you go. Come on, I don't know why it takes too long. Bruh, what the heck? Something strange. Yeah, it's probably... What the heck? Let's try to debug this. Not sure why it's hanging. Okay, so it's reaching this point. And then let's step over. Wow. Bro, what the heck? This is wild. Let's try again. and it doesn't work. What if we don't have this? Trying to identify what's the problem. Maybe the ones that I added now? Kind of weird, but apparently. Why? Why? Could it be that maybe it's hanging on the read call? And also should probably make this buffer once though, instead of every frame. Yeah, but that's probably what's happening here. I'm not sure how to use async. Okay, there you go. So it's hanging here. Interesting. Hold on, why the heck am... Yeah, makes sense. Well, actually, I don't want to hang. Yeah, exactly. So I don't want to hang. I need to find some... Yeah, so can read. So gets a value that indicates whether support... No. I want to know if there is like... Yeah, so basically read hangs, but I need something that doesn't hang. C#, see if bytes available. Gets the amount data that has been received from the network and is available to be read. So I guess that's it, maybe? Probably? So here's what we're gonna do, I guess. If not stream.data available, then return. Okay, let's try this out now. And oh, before that I actually have to incomment this stuff. Okay, so let's actually incomment this stuff. All right. You can tell I haven't programmed in C# for a while. Anyways. What the heck? And handled, no connection could be made because the target machine actively refused it. Huh. Oh, our server client is okay. An existing connection was forcibly closed by the... Oh, okay, I see. So basically while writing, like the client disconnected, so it basically errored. And okay, makes sense. So let's actually now okay, let's actually launch the server. My brain zoned out for a while there. Server start, and let's try now this guy. And let's see. Hello. Okay, so we're getting hello. Hello world. Perfect. Perfect. Now, one thing that I'd like to do here, instead of creating a new buffer every time, what the heck? Instead of creating a new buffer every time, I could just create it once though. Private, like private. I don't know why I can't use that var thing, but anyways, new byte, so byte. I guess it's like this. Okay, cool. So buffer new byte. And now we're just gonna say stream read buffer. I may need though to clear out the buffer. Probably I do, but let's actually just try this out anyways. Hello. And hello world. What if I just said hello? Okay, so apparently no, I don't really need to, I guess. So that's cool. Oh yeah, I don't actually need to because, well, we're already using the bytes count here. So that makes sense. All right, cool. So now let's actually add some messages to the application in the client. So how are we going to do this? So every time, instead of actually making, you know, like console write line, what we actually want to do, so this is the actual message. Var message is equal to this, right? Now we just want to basically instantiate a message scene. So we're gonna, I guess, copy the path of this, I believe. Var message scene. I guess Lloyd. Yeah, gd.lloyd. Okay, cool. Go ahead. Packed scene, perfect. Message.tscn. And so, of course, we're gonna load this guy once. Private message scene. So that would be a packed scene. Message scene. And we're gonna basically say that. And now here, we could say that message. Well, message instance, exactly. So, but it's called instantiate though. There you go. And can I actually give it the type here by any chance? Doesn't seem like it. Okay, fine. Maybe I have to create a class, like a C# class for that, but anyways. So now we got our message instance. So what we gotta do then, let's go to our message instance. We gotta actually change the label. So let's create a new C# message thing here, create. And let's actually open it up there. Message CS. And we're probably gonna have like a public void set message exactly. Perfect. So we're gonna get the node label. Label message label. So let's just get the path here, because apparently unique names didn't work before. So yeah, I don't know why it doesn't though, but well, I hate this. Say oh crap. All right, cool. So we're just gonna basically set the message and that's it. I hate this prompt. Okay, cool. So now let's actually go back to the main.scene, right? And then here, I believe right now, since it have a C# class, we could basically cast it to that, hopefully. And you can say message instance set message. And then we could basically give it the message, I think. And that should probably work out. And after that, we also need to add the child. So, and we gotta actually add it to here to, well, okay, here. So this is gonna be messages, let's say. Let's remove this guy. And we basically gonna copy this thing. And we gotta say, so var, well, private node messages. Okay, and now we're just gonna say here messages is equal to oh crap, get node, yeah, get node. I don't care, just go with node. And I mean, I could have said, you know, VBox container, but it doesn't really matter since I don't care about the functionality of the VBox container. In this case, I only care about it being a node, you know, so I can add a child to it. So message instance.add child. And we're gonna add the message instance pretty much. And yeah, I think so. Unless if I missed something. Is the server still working? Apparently, I guess. And let's say hello. Debugger, okay. Let's actually launch the debugger, really. Okay, hello. What? We got the error only on Godot, I guess, for some reason. That's weird. Okay, what's up with this? Can't add child message. Oh, what the heck I've done. I see. So there should be messages. Okay, let's try now. Okay, hello. Perfect. So we're actually getting back the message from the server. Hello world. Welcome everyone. And just to make sure that this is actually true, 100% true, what we're gonna do is, let's go to the server and let's basically log this out. So info address message, and let's run the server now. So the server is running. Let's run the client. Hello world. Okay. Now let's go to the server. Where is it? And look at that. So this client right here said, well, actually, yeah. There you go. Cool. Okay, cool. So that's lovely. Now what's the next step? The next step. Let's see. What's up with this client? Can be made read only. Sure. And now what? Yeah, let's actually switch from read line. I actually want to use what is it called? Yeah, so we're gonna be sending the message length first. So instead of like depending on being a new line there, we're gonna send the message length first, then the message content, essentially. We could though use JSON instead. Not sure if I wanna go that path already. Let's try this out first. And by the way, in fact, if we launch this thing multiple times, like if we launch this guy multiple times, let's see. I don't think I can launch it multiple times from here though. Oh, oopsies. Let's launch the server. And let's see where we can find the executable. No, what the heck? Okay. Alright, let's actually launch the launcher. And I guess we could probably run it from there multiple times. Or actually, no, there's a better way. We could actually go here, run multiple instances, and we can say run 2 instances. And now we're actually going to have 2 clients run, basically. And that should do the trick. And now if we go back to the server, why it's not printing anything? What the heck? Weird. Yeah, it's not printing anything. What? Try again. Okay, so now it's working. Let's see now. And let's actually remove that. And let's try to run these 2 clients. And you're gonna notice in the server that there's gonna be 2 clients connecting. Yeah, but they're actually not gonna be able to connect though. Unless, yeah. And I know why that's the case, because every time we get a connection, we have to actually make a new task, a new async task, or a new feature. So loop message clear, client connected. So after getting our connection, what we're gonna do basically is Tokio spawn async move, and we're gonna have, let's say, a function handle client, or we could just, you know, just inline it pretty much actually. So and the client that's connected would actually be here after the loop here, and there you go. So this should right now not block when there is a connection. So we should be able right now to accept multiple connections asynchronously if everything goes well. So let's actually try this now. And let's see. So there you go. We got 2 clients connected. Perfect. And if we say hello, look at that. We got hello. Though we didn't get anything here. Yeah, because we're only, you know, like logging back to the socket that we have as the client, right? So that makes total sense. There you go. Okay. So let's see actually how we could do that though. How we can actually give the message to the other clients too. Interesting. I actually don't even remember, by the way. That's cool. Let's go to my old Tokio server. Code Sutaku. Rust Tokio server. No, let me just go to my GitHub. Old account. I think it's probably in my old, or no, actually it's in my new account, my bad. So okay, let's go to look for server here, and let's see how I actually done it, because I really do not remember. Okay, cool. I guess we're probably gonna use a channel, MPSC channel, or client name. So we accept a client, then we subscribe. Okay, stream buffer. By the way, do we actually have a writer? Hold on, what the heck? Yeah, we're actually what? We're actually using write all. I see, makes sense. So I do want to buff writer too, but in fact, if we say this, if we say buff writer is equal to buff writer new immutable socket, this would actually not work, because we cannot get the socket mutably multiple times. So that's not going to work. So what we are going to actually need to do is reader, writer, right? And then we're gonna split the socket into two, the write half and the read half. And then we could actually pass in the reader half. Okay. And then we can also pass in the writer half to the buff writer, basically. Is that the case? We probably need to give it some trait, right? I think so. And then here, instead of socket write all, we could actually use buff writer now. And what's up? You probably need to import the write trait. Isn't that the case? Yeah, probably. So let's see what we got here. Async. Is it async? No. Write txt? Really? No, it's not. What the heck? Buff writer. That's weird. Okay. What the? Let's actually go with socket split. Rust socket Tokio. Well, socket split. No, not stdnet. Well, what this is called actually? Hold on. Let me just go to documentation directly. My bad. Okay. So it splits into a read half and write half. But the halves cannot be moved into independently spawned tasks. Okay. Tokio split string. Come on. I actually already have in my code, my bad. So socket, how did I do it? Stream.split. Yeah. But then why it doesn't work? Weird. Or do I maybe need this guy? Async write ext. Async write ext. Let's try this out. What the heck is going on here? The trait bound write half stdi write is not satisfied. Really? That's exactly what I'm doing. No? Oh, hold on. No. What I'm actually doing there is just reader and writer directly. Is that the case? What? Let's forget about this one. I've been here since day one emoji. This is very weird, man. No way, don't tell me I've... Hold on. No, it is correct. Well, what about buff writer though? Okay, so I hate this, man. So I used the standard library one instead of Tokio one. Man, that suck. Kritos YT, welcome to the live stream. Hey, where are you from, bro? I'm from Morocco. Let's actually see. So this should be from Tokyo. Oh my god, I can't believe this tripped me off again. Okay. And I'm like, bro, what the heck? Okay, let's go. Okay, nice. All right, so that works now. Sucks. Let's remove this up. And here, instead of using right, oh yeah, me too, but it's 2:50 a.m. Whoa. I'm a night owl, I stay the night, pretty much. So, write all messages bytes. My brain is like in, you know, low power mode in the day, you know. That's why I always sucked at school too. Okay, let's see. Oh my god, what the heck? I'm low on disk space. What the heck? Are you kidding me? What the? Why? I mean, I should probably clean up some stuff now. Okay. Cool. So let's actually see what's up now with this. Okay, so let's actually go to Tokyo now. In fact, I think this should be fine. But let's just make sure that this is actually fine. So, and then we can get to figure out how we can actually send the messages between the clients. Hello? What the heck? Maybe I should flush? Is that the case? Hey, can you tell me, did you graduate college, in which branch? I haven't graduated yet. And I picked computer science, so I'm doing a Bachelor of Computer Science. Okay, so it's actually getting into the server, but it's not like making the message here now for some reason. Really? But it could be because the buff writer isn't flushing. That could highly be the case, yeah. That's probably the case actually, so. Use flush await.inwrap. Let's launch the server again. And maybe that's why. Simple question, why Rust? Because I really enjoy Rust. It's the best in performance, and it's well, I don't know, I just enjoy Rust first of all. And it's like best in terms of the server, so that's why I picked Rust for the server. Okay, let's see. Let's see. Hello? And Arab, welcome to live stream. How's it going, man? And it works again. Cool. Okay, so now we actually gotta figure out how to take these messages between Tokyo sockets, so. But it's probably Tokyo sync broadcast channel, maybe. So we would like have a message sender and a receiver. Yeah, exactly. So I think so. So let's try to do this. Yeah. Let's go to Rust now and see how this goes. Server start, client connected. Okay. So let. Man, I keep on zoning out. Yeah, so message channel. Tokyo sync broadcast channel. And in fact, let's just import that. So channel string capacity 10. And yeah, cool. So now it's actually get TX and RX, exactly. So we got so this is an MPSC, which means multi-producer, single consumer. So we're basically going to give a sender to every single client, and then they could use that to send back to the server the message. And then the server would go ahead and send it to the other clients, I think. Yeah, pretty much. So let's see how we could do this. TX mutable RX. So let's see. Message here. So after we get a client connected, we can say TX clone, right? So we're gonna clone this TX, and it's cheap to clone pretty much, I think. So use of moved value. Oh, oopsies. I guess maybe here actually, isn't it? Yeah. So now we got our TX side. We could actually go ahead now and say, so here what we're actually doing, we actually don't even need buff writer right now at this point. Yeah. Yep. So we have just done that for no reason, I guess. Because we're gonna be maybe, well, actually we may need it though. But either way, whatever. So let's actually remove this write all for now. And instead, we're gonna actually send it through the TX. So tx.send, and then we can send the message, basically. And in this case, we gotta clone the message, because otherwise we're gonna move this message from here, which we don't want because we're, you know, we're actually reusing it, basically. Okay, cool. So after sending it, we need some other, you know, future or task to basically put that message into, let's say, a vec, right? And then broadcast. So how can I actually send the other clients the message? I forgot. Let's see. Client message receiver dot receive if message client socket at ADDR not equal to client socket ADDR stream. So we're using this client message receiver. Okay, let's see what this is. So this is message sender dot subscribe. Message sender subscribe. Really? So can I actually do this? Hold on. So rx does, well, I keep on doing that. Okay. So let's see, rx dot subscribe. There is resubscribe. There is tx.subscribe. Creates a new receiver handle. The receive value is sent after this call to subscribe. Okay. And all right, so after getting our tx, I guess maybe we could get an rx, if that makes any sense. Oh my god, I'm probably just tripping. Found. No, it actually doesn't exist here. What the heck? But yeah, you know what? I'm gonna do what I can do best, I guess, is to basically put this into the server and then maybe replicating it. Or in fact, we could do some research too. So, like, how to replicate, well, not replicate, well, replicate messages to or how to send, what should I call this? How to send data to other clients in Tokio, I guess. Between Tokio threads to many other, okay. Okay, I see. Can't we just like actually store the connections, like the sockets? Like, yeah, can't we just do that? But yeah, let's start simple. Let's actually start simple. So we're gonna send it through the TX, and we're gonna actually make a new Tokio thing, Tokio feature, I think. So Tokio spawn, async move, and we're gonna keep on getting messages, basically. And we're gonna try to broadcast that message. Apparently it's trying to say TX to subscribe for some reason. Oh, is there no broadcast channel or something like that in Tokio? So Tokio broadcast channel. Broadcast, let's go. Oh, multiple MPS C. What else there is in sync? The one-shot channel supports sending a single value from single producer to a single consumer. So some computation await. TX dot. Can't we just send like make a one-shot channel for every client? I completely forgot how I actually done this. Damn. But let's keep it simple. Like keep on going crazy. So let's just make a simple vec. So messages is equal to vec new, but since this is asynchronous and multi-threaded, we gotta go with an arc to share ownership. Do we actually want to share ownership? I don't think actually. No. We probably don't need that. Yeah, probably don't need that. Let's see. Messages dot push message. What about that? Let mutable. Yeah, since we're already using the channel, my bad. So I guess that should probably work. And then maybe we could like every time, let's just say print line messages, for example. Print line. Well, of course. There you go. Of course, debug. And let's see. Borrow of moved value TX. What? Should I do subscribe? Yeah, okay, cool. Let's try this out. Method not found in receiver string. Are you kidding me? I'm totally confused right now. Crap. Okay, I see. So So we got the sender. We're saying tx.clone. And why we're using tx here? Yeah, what the heck? Why not just use rx directly? Bro, that's stupid. Okay, let's see. Yeah, makes sense now. Alrighty. Now, let's actually see what's gonna happen. I gotta sleep, it was a good stream. Thanks for coming in. Have a good night. Okay. Oops, he's not here. Let's try this out. And let's see, it should right now be persisting the messages of all the clients in a vec. Hello world. Good night, and you should get some sleep because it's 3 a.m. Yeah. Like, why the heck it's not printing the vec? Oh, because we... Oh, my bad. Alright, cool. But then why do we need the loop here? Bruh. Well, let's just try this out. And let's see. Let's run the clients. Say hello. Interesting. One. Oh. Where we're printing the... Okay, we're printing it here. But why didn't it register, I think, the first message? Interestingly. So yeah, I think we're actually getting all the messages. We're storing all the messages inside the server. Let's see. Bro, what the... Oh, I actually... This sucks. Okay, let's go ahead and run this up. Hello. Why it ignores the first message? What the hell? Rx receive print line. Weird. So 1, 2, 3. So yeah, we're actually getting the messages now in the server. Interesting. Now I need to realize how can I actually... Yeah, like what happens if we just... You know, like store all the sockets that we got stuff, or like can't we actually just get it from the listener directly? I don't think so. Probably not. I don't think that's how it's supposed to be, like listener connect. No, probably not. I should probably store it myself. Yeah. So, okay, sure. Well, sockets. Let's call it sockets, I guess. Is equal to vec new. And then we could, I guess, basically socket stop push socket, but we actually have to, but no, that's gonna move it. Yeah. Though. Can't I just actually? No, that's probably not gonna work. Okay, I should probably get some rest at this point. But yeah, we have actually created, at least right now, the UI. You know, a basic UI for now. I'd like to even support voice if I can, because like Godot could actually give me the microphone, you know, audio data. Then I could hopefully send it to the server and broadcast it. So yeah, I just have to realize, right? So we're actually storing the messages now in the server. We just need to realize how we can basically broadcast it to the other clients now, essentially. But yeah, other than that, that was interesting. That was it for guys for this stream. Thanks for Isa Ismail. Thanks for Slot Flappy. And thanks for Daniel Ahmed Result He and Krichos YT. Thank you all for coming in. Thank you all for tuning in. And see you in the next one. Goodbye, everyone.